So coming to the how part, so we need to start from source. So actually we need to build the OpenCV from source, because for Python we can just use import OpenCV Python, but for like this darknet is written in C++, and for other language we need to build the OpenCV from source. So just download the this file. All those links and the file details will be there in the description. Again, I will be planning to build a what we say blog post, so you can follow me or you can check that blog in my cvrrocket.ml or in my blog. So the blog will be in that website only, 123 cvrrocket.blogspot.com. So yeah, so details will be given in the description. And this video is brought to you and sponsored by CVR Rocket. Again, if you don't know, we provide solutions, products and services in the radar of AI, machine learning, deep learning, and for like websites, apps, etc. So you can just check it out. And we have some platforms. Coding Now platform is actually for coders, those who have like interest in this coding department. You can just check it out. And again, some of my projects are also, all the details will be there. You can anonymously go, anonymous login, all those options. Again, video is taken in the YouTube channel, you can just check it out. And this is a CVR Learn, where we have the courses, and you can just check it out, those things. Like these are some courses. Again, donation is going on. You can also shoot up for the donation, this thing. And I'm giving some courses, promo codes, benefits too. And this play plug, it's actually like plugins, web plugin, just socket chat. Others are other plugins and courses are in like staging. Again, existing user can use though, so you can just avail this, all the payments with card, and again with Stripe, PayPal, all those UPI payment gateways, all those enabled. You can just check out these things. And at last we have like CVR games, this web game. If I suppose there are two games, you can just log in from here and just play like Decoded and quiz game. And again, those videos also there in the YouTube channel, so you can just check for all the details. Shoot out to description box below. So basically we need to download that file, and again contrib file from GitHub repo. This also need to be downloaded, because these have additional modules apart from this OpenCV main module. So, and again we need to build this module. Actually we need to give this path to CMake. CMake is actually like which will try to build the make files. So all those binaries will be built to this path, actually this one. So I'm just giving this destination file over here, and then we'll be having one OpenCV solution file. Yeah, this one. So just open that with Visual Studio. Again, you need Visual Studio, so all those links will be given. And then here all build is there, just build that, and after building that, install also. So if you get any problems, errors, just contact me. All my social tags will be in the description, or you can just DM me Instagram, so that I will try to personally help you out for getting out of your error or any problem. And then what we can basically like so once you have built that, so you can just go to command line from here, and then just check like import OpenCV, or like what else, like you can just check the OpenCV version. If it's coming, means that means you have built your OpenCV from source. Then it can be used for obviously for Python you have module itself, OpenCV for Python -Python, and for C++, for other language also it can be used. And again we need to have darknet. Actually it's written in C++. Again you need to have darknet. Actually it's written in C++, so we can again convert that to use with a Python. Again we will be having Python wrapper for object detection and object tracking separately. For now, if you want to detect something, you can use this darknet as a framework for YOLO actually. So YOLO is like implicitly for C++ written, so using darknet framework. So this is a framework actually, and again we need to feed this data to the CMake, and we will use the source as this one binaries, where we need to store binaries as we did for OpenCV. And again OpenCV we have, so everything like video, images feed, webcam feed will be used directly. That's why I said build the OpenCV from what we can say from source scratch. So yeah, this is the directory where we are going to store. Again in this binary we need to have like information. Whenever we configure it, we need to give information like CUDA. If you're going to use CUDA, again For NVIDIA, it's a separate architecture. CUDA-NN, if you're going, I like CUDA-NN half don't use. Again, if you're using Linux, then only use, it's better. So you just need to check those information, and yeah, this information. And then if you are using, you have GPU actually, then only will be having CUDA, NVIDIA graphics card, then only will be having CUDA architecture. Configure, generate, all those if will happen means we'll be having in this build folder, all those these files will be generated, and we have separate solution file. Open that using Visual Studio. Again, go over here and build it. After building, any errors if you get, just ping me out in the social tags Instagram. And again, install, you need to do build. Yeah, so pretty much that's it we have to do. And again, I just got to remember, do subscribe guys, so that like every other person will also be able to watch this videos, like this video, so that it helps in ranking. And again, hit that notification bell, all those, because like you will get timely notification whenever I upload my new video. So yeah, again, and one more thing, in darknet directory, include this file from, it will be DLL files, all will be there in the libraries or binary section. Just include this file in the root section. It will just cause some weird error. You can just bring that here, so that you will be out of that error. Again, remember that whenever you are just configuring OpenCV make file in CMake, then just include enable from external or extra modules, so that it give this path source information, like this path as source to that. That means, so we need to include this OpenCV contrib, this part also. Again, coming to the custom training, you can use this thing actually, open image dataset v6 plus by Google. So all those images will be there. As you can see, these are, so these many categories, all the classes. Again, something like 80 billion like images or so, correct me if I'm wrong. And as you can see, we'll explore means we can just select random category and options. So display boxes, like from all categories. And again, type segmentation, you can just go to detection for now. So we'll be having the rectangle box or contour boxes. And again, in option, you can select display boxes from all categories. You can just uncheck that, so it will just show dices and what are the category we have. Student and subset train validation test we have. Train means more images, validation test is obviously less images. And in all the commands, and again, documentation will be there in the description, so how to download these images. And again, this is a small module, this toolkit actually, so details will be there in the description again. So what it does means, once we have downloaded the images like this over here, we have CSV folder for class description, train description. So in data set train, I have chair and human hand. And again, one more, in classes.txt, I'm just using human hand as first one and chair as second. So this is the 0th index one, and this is the first index one. So again, if you go to data set train, so chair if we have, so once we have downloaded this, the label actually how we will get. So in this label, as you can see, we'll get chair, chair, but YOLO doesn't accept like this. And these are the coordinates, and how it will calculate the coordinate, it will be there. What YOLO does is, it needs some information like this. So one means actually whatever we kept this, like this one, as you can see, this is a chair information. So one means whatever we given over here, so chair. And again, if it's human hand means, so it will be 0 obviously. So once we go over here, human hand, if we'll go, so like this open dataset image is give like human hand, but YOLO doesn't accept like this. So we need to run some script, and it will generate like this. 0 means human hand, 1 means chair. So that script is basically this. So yeah, just you can just see the script. I mean, again, have the links. So this just basically does all the works. So it will manually or like automatically converting every that images over there. So you can you have like your burden for manually converting has been like reduced. Again, it will be difficult manually if you want to do. So yeah, that's it. So again, custom detection, again it can be done like custom recognition using the image data set. So it can also be done using label mg. You can just manually get the Google photos, Google images photos, and again one script you can run that I will be using, like showing you in the description. So it will extract all those things from the Google images, and then you can have, like, again in TensorFlow, what we need to do is we have to change from XML to CSV. The same thing we are doing, I've just shown in the CSV dataset also. So we need to, like in label.mg software, we need to do, and we have to manually draw like contour. This is chair, this is hand, and we have like one option over there in the label mg type. If we select the YOLO type, it will run like directly generating the YOLO version supported type annotation. So that 01 instead of train and chair, 01 will be getting, which I've just shown previously. So coming to data darknet, here what we need to custom training we need to do. How custom training? Again, you need, use this CMake file, this make file, and in CMake we will select CUDA and so NVIDIA CNN. So all those will be the checkbox you have to tick, and then we are going to go over here, like in configuration file. In configuration file, you need to take YoloV3. These are tiny, so we need to select a weights in the nothing but in the whole new, like we have the layers, right? In that we have artificial neurons, so what weights should be sent? So those pre-trained weights you can use, again transfer learning, making using the pre-trained weights and using your custom weights, the same thing which I am done. So it will give you a better result. So you can just this is a config file and custom file. Again, testing, and this testing time you have to uncomment this. Training time you have these things, and the subdivisions, batches means how batch size, how many batch for one batch, how much the size should be. And like this one, as you can see, max batches, like iterations 4000. So this into this, those many images will be there obviously. And steps, this keep to 80% of this max batches and 90% of this max batch. Again, try to keep this 4000 for one image. If for two images, again this is just formula I would show, but at least keep 4000, even it's a one image, like one image data set, human and one image, like that. And again you have convolution filters, so all those formula I will just show you. You have to change the random value and filter values over here. So yeah, change those configuration and save this file. And then what we, then go to this data, and here what, again darknet, you can just download that repo. And here what you can do here, object data. So you have to specify, actually I'll just open it for you. Object.names, actually you have to specify what are the classes you are using, human, hand, chair. And you need to object.data also, you need to specify like classes we are using to train. So path, you need to specify valid path, validation path, test.txt. And this train and text is .txt. I will just show you. Names is like where are the names, this one which I have just shown you. And backup means all those custom train weights will be saved in this folder. So yeah, I will now show you this text thing. So all the images will be there in the object file for now. All the chair and like hand I've just combined. Again, you can use this thing to combine, one syntax will be there. So instead of using different folders, you can just combine the same folder. So this train dot text is nothing but this is a path, the path of all the images. So that and again this generated by this script, where this generate train, yeah, test I'm not in, just I'm want training data. So yeah, from this script, again this will link. So you can just this normal Python script, simple thing. So you can just take the paths, and that path we have fed in the configuration itself, not in configuration, in data we have kept in the data folder. As I've shown you, this is the train text and text. So the text file have the path information of the images, so that whenever we are training, so from that path the images can be taken. So yeah. So again, this is the same thing. This is a webcam with using picture. This is a wrapper for Python actually. So using the arcade only, just a wrapper using some functions. We can just use the Python and do everything. And this is a tracker using deepsort and tensorflow, which you are going to do. So again, we need to activate. You can use a Anaconda like script, and there you can activate, deactivate. You have just create environment so that all modules will be for that environment only. And again, it makes little easy for everything, object tracker. So I will just show you the syntax and everything. The details will be there in the description too. So with this we will going to do project for tracking and detecting face, hands. And again we need to, in the weights folder, we need to have this custom weights, and we need to convert that to TF, like tensor fields. In tensorflow we have tensorflow fields. So in that format we have to convert for this, like wrapper for deep sort, like in darknet. we can directly use those weights file itself. As you can see this in the darknet, which we have the weights in the backup will be generating weights. So these are the 2000 weights. So for I just run for 2000, but it's not giving me accurate results. So for 4000 iterations it will give accurate results. Again it will be generate for 1000 it will be keeping a backup, so you can just leave it overnight. Again, training it will be taking a few hours, and testing can go for a few days. I did the same thing for few hours. I just left for training, so it will be keep on training each iteration, and few days I tested with webcam all set up as shown you as. So the last weights, final weights, you can just feed using darknet, but using if you're using wrapper, then convert this to TF, and the syntax will be given, the description of those documentation will be given how to convert those. So yeah, and the detections here, you will be all storing your detections folder, like videos, images, webcam videos, anything. So here you need to have weight, you need to custom weights. Once you have generated, keep the weights over here. And what else you have to change in this wrapper is in data section, and videos is like source videos, whatever you will be having. Images, labels, in the labels section we need to have coco.name. Actually, common object in context, this is a coco data YOLO uses, like in pre-trained models, all those things like persons, chairs, bikes, motorcycle, cars, all those common objects in context. Actually, it's nothing like I will show you. Yeah, this one I was talking about common objects in context, and this is a YOLO like official documentation you can just go through. For Linux users it's pretty much easy. For Windows I just set some steps, just follow that and be okay for you too. And now coming to labels, and here you need to have for custom detection names, human hand, and chair you need to include over here. And pretty much like that's it. Yeah,